Trigonometry 2 on bearing and distance. So go and watch other, I've done a lot of video on Trigonometry 2. Watch them, watch other series. Okay, so now look at this example. How do you solve bearing problem? Very, very simple. Now follow me very fast. If you have this kind of question, alright, to solve a bearing problem, it is always advisable to sketch. Have a sketch of what you want first. If you are not sure, just a little sketch of the diagram. Okay, so a boat says 6 kilometers from point S. Okay, so and then the bearing of 65. So the bearing will be going upward. So let's assume that this is my point S. Okay, and every point you must have a cardinal point, and this is the north. And they say it sailed what 6 kilometers, and this is 6 kilometers. Let's say this is my 6 kilometers. Okay, point S on the bearing of 65 degrees. So the bearing always starts from the north. You start your bearing from the north. So this is 65 degrees. You move 65 degrees, and then on the distance of what 6 kilometers. And while it is moving, it's sailing on the bearing of this to a port, another port Y. Okay, so that means it will come to another port Y. This is north, and this is port Y. Okay, and then when it comes to port Y, and thereafter 13 kilometers on the bearing of this, it left port Y again. From here down to this place is 90. Alright, so 90 to this place is 180. So but this is 136. So 136 will be somewhere here, and they say it is what 13 kilometers. So that means it is assumed that 13 kilometers will be longer than 6 kilometers. Okay, so this is to another port. You see it now. This is north, and this port, they told us that this port is Z, port Z. Okay, and this bearing is from here down to this place, which is 136 degrees. 136 degrees. Alright, so now, and then what is the distance and the bearing of the boat from S? So that means I will have to join this to X now. Alright, so it's a sketch. You need to sketch. Alright, this is a sketch which you actually need to sketch very well. Okay, so this is my sketch. Let me draw this line again so that it will be more neater. Alright, so this is now my sketch. I have my sketch now. Alright, so this is it. Now we are asked to find this space. If here is capital letter Y, here is small letter y, so that's where they are asking us to find. Okay, and they say here is 13 kilometers. Okay, now that they have given us all of this, now we are going to do a little analysis. If here is 65 degrees, alternative angles are equal, so this angle is also equal to this angle, which is 65 degrees. Alright, then if from here to here is 90, and here to here is from north to south is 180. If the angle move from here to this particular place, and it is 136, so that means the remaining part here will be what? The remaining part here will be 180. 180 minus 136, which is 44. That means here is 44 degrees. So that means I can get the whole of this angle now. The whole of this angle now will be 65 plus 44. 65 plus 44, which is going to give you 109. Okay, so this I've gotten this angle now. Okay, so and if I've gotten this angle, this side, I can also find this side now. How do I find this side? To find this side, what am I going to use? I'm going to use my cosine rule. I've treated cosine rule already. You can go and watch it in other series. Alright, cosine rule, to find this y now, it will be what? Y squared equals to the two sides. The two sides is what? Two sides of x squared plus z squared. Alright, then minus 2xz, then cos capital letter y. So my y squared, which is the distance they asked me to find, will be equals to my x. X is now 13. That is the direct opposite of this x. Is now what? 13. Let me clean it so that I'll pull it out for you to see. This is x side. So this is the direct opposite of x, which is 13. It's going to be 13 squared then plus z. This is not 3, this is my z, small letter z. So the z now is this 6 kilometer, 6 square, minus 2 times 13 times what, 6 times cos, my y is 109, so my y square is going to be 13 square is 169 plus 6 square, and 6 square is 36. Alright, 36, then minus 2 times 13 times 6. 2 times 13 times 6 is going to be 30. 2 times 13 times 6, 156. Then times cos 109 is going to give me minus 0.3, 25, and then 6. Alright, so this is y squared, and this y squared is going to be equal to 169 plus 36. 169 plus 36 is going to give me 205. The minus as this minus is changed to plus. Then 156 times 0.3256 is going to give me 50.79. So y squared will be equals to 205 plus 50 plus 50.79 is going to give me 255.79. So to remove this square root, you take the square root of both sides, remove the square, you take the square root of the both sides. So we are going to have square root of 255.79. Alright, so this is going to be equals to, take the square root of this, we are going to have 15.99. So approximately, we are going to have 16 kilometers. Alright, so the distance of this x, z from x is what? Is 16 kilometers. Now the next question they ask us to find the bearing of what? Of x from z. The bearing. That means what we are looking for. We are looking for the bearing is always taken from the north. We are starting from the north here, which is what? 90. This is what? 180. This is 180 plus 90 again. 180 plus 90 is 270. But remaining this small space, we don't know this small space. Okay, so for us to know this small space, we need to find this angle, this small angle here, so that this angle is alternative to this angle, so that we can add this to from north down to this place. So how do we find this angle? To find this angle, we can first of all find the whole angle here first. Let's say the whole angle here is better. Alright, so let's say this is better. To find this angle, what do? We can still use our cosine rule. If you are using your cosine rule to be cos beta to be equals to what? A. Not A, we are not using A here, so we are using x, y, and this angle of x is what we are looking for. So therefore we are going to be using y squared plus y squared, side of y squared, and then side of z squared minus side of x squared. Alright, x squared is my x squared is small x all over 2yz. Alright, so this 2yz, small z, let me use that one. So this is going to be cos beta to be equals to our y, we just find it to be 16 squared, then plus our z, look at our z here, and the opposite is 6 squared, it's going to be 6 squared, then minus our x. Our x is 13 squared, all over 2 times 16 times 6. 2 times 16 times 6. So our cos beta is going to be equals to 16 squared. 16 squared will be 256, then plus 6 squared. And 6 squared is 36. Then minus 13 squared. 13 squared is 169 all over 2 times 16 times 6 and subtract. 256 plus 36. Okay, then minus 169 is going to give me 1, 2, 3 all over 192. So divide it. If you divide by 192 is going to be 0.6406. Alright, so our beta now will be equals to cos inverse of 0.6406. So beta, this angle will be equals to cos inverse, press your shift, press your cos, then type in this number 0.6406 is going to be giving us 50.16. So approximately it's going to give us 50 degrees. So now, if we are plotting our beta to be 50 degrees, the whole of this place is 50 degrees. Remember? Now, if this place from here to here is what? Is 45. Remember? From here to here is 65 rather. And then this is from north to east. From north to this particular side, the first quadrant, in the first quadrant, all of them is 90. From here to here is 90. So if we have taken 65 out of 90, the remaining small part now is 65 minus 90 minus 65 is 25. So here, this particular small space will be 25. If this small space is 25 and the whole of this angle is 50, then that means 25 plus this small angle here is what will give us 50. So what I mean is that if beta, the whole of beta here is 50, the whole of this space is 50 now, and small one part of it is 25. So 50 minus 25 will give us this small space. That is 50, which we have found to be our B. That means our B is what? Is 50. We just find it now. 50. So if the whole of this place is 50 and part of it is 25, if you take minus 25 from it, it's going to, that is, this remaining part too is what? Is 25. So 25 plus 25 is 50. So now the thing now is that if here is 50, if here is 25, this down part is 25. Alternative angle are what? Are equal. That means this particular place too is 25. Are we seeing it now? So the bearing of x from z will now be what? Taking it from North Pole, it will be now be 90 degrees plus the second quadrant will be what? 90 degrees plus the third quadrant. In that third quadrant now, that particular third quadrant, we discover that this is 25. If this part, we are supposed to, this is first, second, the third quadrant is what? Is 90 degrees, then plus this from this, the fourth quadrant now, what we got in the fourth quadrant is just 25. So then plus 25 degrees. So this is going to be equals to 90 plus 90 plus 90 plus 1 to 10 plus 20, 25 is going to give us 295 degrees. 295 degrees, and this 295 degrees is the bearing. And of course, and this bearing is what? 295 degrees. Alright, so now let's go to example 2. You see, an aircraft takes off from an airstrip at an average speed of 20 km on a bearing of 52 degrees for 3 hours. So let's start like this. Let's assume that let me say this is my A, and this is just the starting point of the aircraft. Alright, so and it took off 52 degrees. So 52 degrees will be here. We have 52 degrees here. And then this 52 degrees is for 3 hours and it is 20 what? Kilometer. Now let's say this is 20 kilometer. And then it changes course again and fly on the bearing of 28 degrees. So at this particular point, after reaching this place, alright, After reaching this particular point, all right, then it changes its course. This is not cool. It changes its point and flew again 28 degrees. And this 28 degrees, we are told that 28 degrees. And let me clean this line so that it will be bold enough. This is 28 degrees, and it flew for 30 kilometers. Okay, so now that it flew for this 30 kilometers, this is another bearing again. Okay, flew for 30 kilometers. All right, so now what we are told is that this is my north pole, and this is what 20 what? It flew 28 degrees. 28 degrees, and here it flew here for 52 degrees. 52 degrees, and then we are told that if it flew like this, then for 30 kilometers for another 1.5 hours, find its distance from the starting point. So this is the starting point. Alright, so the distance here, that means we are asked to find this distance here from the starting point. So this starting point, you have to join. Please, if you are using paper, you can use your ruler. Ruler will be more, ruler will make it more straight. Okay, so please use your ruler to be more straight than my own. Okay. All right. So now this is the starting point. So let us this is A and this is B, and then let's say this is C. All right. Now they ask us to find the distance from this C to A, that is AC. So, and the direct opposite of it is small letter b. So that is what we'll be finding. We want to find our b first. Now that we want to find our b first, looking at this, you will agree with me that to find this particular b, now if here is 30 kilometers, here is 20 kilometers, and then how do we find the remaining angles? That is what we are going to be looking at shortly. Alright, so if this particular place is what is 52 degrees, from here down to this place is 52 degrees. Now what it means is that you are left with what? This particular small space. Now this small space now, there is this small space here. Okay, if you take 90, this on the first quadrangle. This first quadrangle, if you take 52 for 90, so 90 minus 52 degrees is 38. That means this particular small space here is what? Is 38 degrees. If small space here is 38 degrees, then that means it is what? It is alternative. This 38 is alternative here to this angle. So here is also 38 degrees. If here is 38 degrees and here is 28 degrees, then this is a full quadrant 90 degrees. Here is a full quadrant 90. So 38 plus 90 plus 28 will give us this angle. Okay, will give us this angle, this particular angle. Now let me make it big so that you see it. So that is 90 plus 38 plus 28 will give us this angle. Now this angle is maybe it's very big, okay, but don't worry, it is still part of it. So here will be what? 156 degrees. So this angle that is facing B now is what? 156 degree. If it is 156 degree, then we can now use our cosine rule to find our B. Remember that our cosine rule, B squared is equals to, will be what? Will be side of what? C and A, which is what? A squared plus C squared. Alright, so minus 2AC. Okay, then cos B squared, cos B rather, not squared. So my B squared now will be equals to My A, what is my A? Opposite of A is 30. Alright, so opposite of A is 30. So that 30 is what? 30 squared. Then plus C. Opposite of C, this is C, which is 20. Which is 21 squared. Then if that is the case, we have minus 2 times 30 times what? 20. Then cos, multiplied by cos B is what now? 156. Okay, so let me manage this please. Cos 156. So this is going to be B squared equals to 30 squared is 900. Then plus 20 squared is 400. Then minus 2 times 30 times 20, 2 times 30 times 20 is 1200. Then times cos 156. Cos 156. Cos 156 is minus 0.9135. Alright, so now our B squared will be equal to 900 plus 400. 900 plus 400 will give me 1,300. Then minus times minus will be what? Will be plus. Then 1,200. 1,200 times 0.9135 is going to give me 1,096.2. So our B square now will be equals to add two of them plus 1,300, which will give me 396.2. So my B now will be equals to square root of 2396.2. If you find the square root, B now will be equals to the square root of this. So this number will be what? Will be 48.95. And that 48.95 approximately is 49 kilometers. So the distance from A to C is what? Is 49 kilometers. Now the next thing they asked us to find, they said that the bearing of the aircraft on the airstrip. Now this is where the aircraft is now. Okay, so and started from here to this place, and then from here to this particular space. So what is the bearing of the aircraft? They say the aircraft take off from an airstrip at the average speed of this. So the bearing, for us to find this particular bearing, there is something we actually needed to do. So what is the bearing of this particular aircraft? The bearing of the aircraft from the airstrip. This is the airstrip now. This is the airstrip. What is the bearing of the aircraft? This is where the aircraft is now. From this airstrip. This is the airstrip. The airstrip is the starting point. So what is the bearing of this aircraft here now from this airstrip? So we are going to find 90. Right? We are going to find from the bearing will be 52 minus this small angle here. Alright, so this small angle. So that means we need to find this angle first. And then let's call this angle maybe beta. Let's find this angle. So if you find this angle, 52 minus this bearing will give us, because what we are looking at actually, this is not. So the bearing is from here to here. Okay, but what we have before is that from this particular place down to this place is already 52. It's 52 degrees. So if it is 52 degrees, so if you want to find this small space, then we have to take, if you find this angle, which is better now, we can be able to find this remaining part, which is now 52 minus beta, it will give us this. What we mean is that this is 52 minus what? Beta. Okay, so now let's go and find beta now. To find beta is in this triangle, and then we can use sine rule to find our beta. So we can use sine rule to find our beta. How do we use sine rule to find our beta now? We are going to find the side of what? Of beta is given, which is A. And that is what? That is 30, which is what? A. all over sine capital letter A, which is equals to, we can now use this B and this side of B. The side of B, the B all over sine B. Okay, so our A, the side of A is 30. 30 over sine, our A now is representing the beta, which is equals to B, our B, the side of B, we just find it now to be 49. 49 all over sine, the angle is what? 156. 156 degree. So now we cross what? We can cross multiply. If you cross multiply, what you are going to have is that you are going to have 49 sine beta to be equals to 30 times sine 156 sine 156. This is 0.4067. So this is going to be equals to, my sine beta now will be equals to 30 times this. 30 times 0.4067 will give me 12.201. Then divided by the coefficient here is for sine beta is 49. So by 49, this is going to be equals to, divided by 49, it's going to give us 0.249. So therefore, our beta now will be equals to sine inverse. Alright, sine inverse of 0.249, which is going to be equals to, shift, press your sine inverse of 0.249 is going to be 14.4, which is approximately 14 degrees. Okay, so if beta is 14 degrees, so therefore the bearing now will be equals to what? 52 degrees minus 14 degrees. And then 52 minus 14 degrees, 52 minus 14 degrees is going to be 38. Alright, 38 degrees. Remember, I told us that here, from here down to this place is 52. So the bearing of the aircraft now from the airstrip, which is the starting point, is what? Is from here down to this particular place. This is what we are looking at. Alright, so if this is the case, 52, which is from here down to this place, minus the beta, which we just find inside here now, which is 14, okay, minus it will give us this. So, and that is what? We just find it to be what? 38 degrees. Alright, so thank you. This is Benora Academy. We are done with Trigonometry 2. Feel free to subscribe. Subscribe now, it doesn't bad. Alright, thank you very much. Like, comment, and share. Thank you very much. Thank you.